Hello students, so we will be seeing chapter differentiation, and since we have studied the topic previously, we are on the last part of this chapter, which is trigonometric derivatives. Okay, so derivatives of trigonometric functions. So these are the formula that I have already written on the board. So these are the formulas that we are going to use for our next exercise, which is 19D. So let us see. First, derivative of sine x is cos x. For cos x, it is minus sin x. Tan x is equal to sec square x. Cot x is minus cosec square x. Sec x is sec x tan x. And derivative of cosec x is minus cosec x cot x. So if you see, whatever trigonometric function begins with co, you will see that the derivative is negative. This is just a thing for which you can always remember that derivative of cos is negative sin x, cot is minus cosec square x, and cosec is minus cosec x cot x. So we'll be using this formula apart from the formula that we have studied earlier, which is derivative of x raised to n, which is n into x raised to n minus 1. Okay. So let us begin with the exercise and keeping this formulas in mind. So first is sine 5x. So we need to find the derivative of sine 5x. So let us take sine 5x is equal to y. Okay, this is my function y. And therefore differentiating with respect to x. So we are differentiating both sides with respect to x because my variable is x. Okay, so this will give me dy by dx is equal to d by dx of sine 5x. Okay, so now from the formula I can see that derivative of sine is cos. So my sine x will become cos x. So once I derive this is cos 5x, but my x also has a coefficient along with it. So what will happen? We have to take derivative of this function as well. So this is now cos 5x into derivative of 5x. How is this? We have seen this in the previous exercise. Okay, so now derivative of 5x, since 5 is a constant and is multiplied with x, so 5 comes outside of this operator and this is just derivative of x. So derivative of x with respect to x is 1, right? So this becomes this 5 I am writing at first, and this is 5 into cos 5x. Therefore, the derivative of sine 5x is 5 into cos 5x. Okay? So first step, take this function as y, differentiate both sides with respect to x. And once you differentiate, apply the formula. For sine, the derivative is cos. And therefore, sine 5x becomes cos x. But inside a function sine, we also have another function. Therefore, what we are going to do, we are going to take derivative of that function as well. Since we have seen this in the differentiation theorems, which was there in the previous exercise. So 5x, now this for derivative of 5x, it is just 5. So this is the final answer. So derivative of sine 5x is 5 into cos 5x. Okay. So let us see the other example, which is tan 6x plus 11. Similarly, we will go step by step as we did in this one. So you take let y is equal to tan of 6x plus 11. Okay, the first step, we are taking that function as y. Next step, differentiate with respect to x, because my variable tan is in, with the function tan is in x. So we are differentiating with respect to x. So you get dy by dx is equal to d by dx of my function, which is tan 6x plus 11. Okay. Now what is derivative of tan? From this formula set I can see derivative of tan is sec square x. So this becomes tan 6x plus 11 becomes sec square 6x plus 11. Now again there is a function inside a function. So we will derive this as well, and this becomes d by dx of 6x plus 11. Now how do we derive this 6x plus 7? The same case as we have done it here. So derivative of, this is a plus b, so we will derive a and b together because this is according to the property of the derivative which we can do. So this is 6 square 6x plus 11 into derivative of 6x is 6 and derivative of 11 is a constant, derivative of constant number is 0. So this is 6 plus 0. So which gives us only 6. So my final answer now is 6 into 6 square 6x plus 11. So this is my final answer. So derivative of tan 6x plus 11 is 6 into 6 square 6x plus 11. Okay? Clear up in here? Come on, let us take the other question. Last exercise we have also seen what is derivative of u into v and u by v. So let us take some example from a question involving that. Let us see what do we have in the exercise. So here is the question, which is x square into cos 5x. Now if you see this question, there are two functions in this. There are two functions with multiplication, right? X square and cos 5x. So our first step is, of course, let this function is equal to y. So y is equal to x square into cos 5x. Next step, differentiating both sides with respect to x, because my function is an x. So this becomes dy by dx is equal to d by dx into x squared cos 5x. So now here we have multiplication of two functions. This is u, this is v. So you will apply the uv rule, which is v into derivative of u plus u into derivative of v. That means if you have two functions, so you can take second function into derivative of first plus first term into derivative of second. So this is how we can remember it. So this, by applying uv rule, you get, I'm taking cos 5x outside and derivative of x square plus, now this x square is outside, and derivative of cos 5x. Okay, so now this cos 5 here is as it is, and derivative of x is, this is in the form x raised to n. So x raised to n, what is the derivative? N into x raised to n minus 1. So this is 2 into x raised to 2 minus 1 plus x square is written as it is, and then derivative of cos 5x. So derivative of cos 5x, what is derivative of cos? We know derivative of cos is minus sine. So this is minus sine 5x, but my x has a coefficient. So I'll take the derivative of 5x as well. So now derivative of 5x, I'm writing it here directly. So this 5x derivative is just 5. 5 is outside, so it is d by dx of x. So derivative of x with respect to x is 1. So therefore you get 5. Now you can write this in the standard format, and this becomes 2x. So this is 2x into cos 5x plus, or rather this is minus into plus. So I'll get minus 5, I'm taking in front. So this is 5x square into sine 5x. So my derivative for x square into cos 5x is 2 cos x cos 5x minus 5x square into sine 5x. First step, take y is equal to this function, differentiate with respect to x. Since this is in the form u into v, you apply uv rule here and then you derive. Okay, and then just simplify and write it. So you get the answer. So this is according to the uv rule, right? Come on, let us take one more question which will cover our topic u by v. So we have this question, cos x upon 5x. Okay, so let us see this. So now this is in the form u by v. So our first step, as obvious, is let this function is equal to y. So now differentiating this with respect to x on both the sides. So differentiate with respect to x, and therefore I'll get dy by dx is equal to, now about u by v rule, so v into, v is your denominator, v into, let us first write this as dy dx of cos x upon 5x. So now applying u by v rule, so it is denominator into derivative of numerator minus numerator into derivative of denominator whole upon the square of the denominator. This is u by v rule. V into derivative of u minus u into derivative of v upon v square. Okay? So now let us derive it. So you get 5x is here as it is. Derivative of cos is minus sine. So this is minus sine x minus cos x into derivative of 5x is 5 upon 25x square. Okay? So if you see, you have 5 in this term as well as in this term. So if you want, you can cancel it out. So this becomes minus sine x into 5x upon 25x square. This minus sign here, and this is 5 cos x upon 25x square. So after this 5 are 25, this x and x gets cancelled. So you get minus sin x upon x minus 5. Okay, we can cancel this 5 are 25. So this is cos x upon 5x square. So this is derivative for cos x upon 5x. So we have applied u by v rule. So using these rules, now you can go for the other questions. Okay, let us cover one more question in this. Question is to find the derivative of sec ax minus b upon x square minus 2. Okay, so again this is in the form u by v. So let us first take this as the function y. So this is y. Now differentiating the functions with respect to x, differentiate with respect to x, and therefore I get dy by dx is equal to dy dx of sec ax minus b upon x square minus 2. So now this is u by v again. So what I have to do, I'll apply the u by v rule, and according to that it is x square minus 2 into derivative of numerator, which is sec ax minus b minus the numerator, which is sec ax minus b into derivative of the denominator. Okay? V into derivative of u minus u into derivative of v whole upon v square. Okay? So now we have x square minus 2 outside the derivative, so we will write it as it is and write the derivative of sec. What is derivative of sec? So derivative of sec is sec x tan x. In place of x we have ax minus b. So this becomes sec ax minus b tan ax minus b. So this is sec ax minus b into tan ax minus b into, since this is a function inside a function, so we will derive the function which is inside the bracket as well. So now a and b are constant with respect to x. So derivative of ax would be like we derived 5x earlier in the problem. So this ax, derivative of this ax would be again, this is a and b's derivative is 0. So therefore this is into a. Okay, this was the derivative of just the first term. Now the second term. So this sec x ax minus b is outside the operator. So I'll write it as it is. So therefore it is minus sec ax minus b into derivative of x square minus 2. So this x square is in the form x raised to n. Derivative of x raised to n is n into derivative of x raised to n minus 1. So this is 2x and hence it is minus 2 minus 2 derivative is 0. So I have just written 2x. This whole upon this denominator will be x square minus 2 whole square. So rearrange the terms. Let us rearrange the terms and write the final answer. So yes, so what's the final answer? Here this a goes in the front. So this becomes a into x square minus 2 since the place is compact. So I am writing it very close to each other. This is sec of ax minus b into tan of ax minus b, this minus sign, and this 2x into this function. So it is minus 2x into sec ax minus b, this whole upon x square minus 2 whole square. Let us write this equal to sign here. So the derivative of sec ax minus b upon x square minus 2 is this. Okay. So first we have taken this function as y, differentiate both the sides with respect to x. This is in the form u by v, applying v into derivative of u minus u into derivative of v upon v square. Define the derivatives, rearrange, and that will give you the final answer. Okay. So these were the typical questions in the exercise 19D. And similarly, using these formulas and the previous exercise ideas, we can solve the other question.